Hello everybody, this is my new video and this video is about multiple spanning tree protocol or MST. This video was about to become very big, so I decided to divide it into two parts, and this video is part number 1. In part number 1 I'm gonna review such topics as pros and cons of 802.1d, PVST, MST. I'm gonna review MST region boundaries. I'm gonna review what is MST instances and IST instances, MSTIs, M records, and I'm gonna speak about MST configuration, verification, and tuning. So let's get started.
Pros and cons of 802.1d. The original 802.1d standard supports only one STP instance for an entire switch network, also called Common Spanning Tree (CST), where all VLANs use the same topology without possibility to load balance traffic across links by blocking for specific VLANs on one link and for other VLANs on alternate links. In a network running CST, the following are true. No load balancing is possible. One uplink needs to be blocked for all VLANs. The CPU processing power is spared. Only one instance needs to be computed. So, as we can see on this example, all VLANs are blocked on the uplink between SW3 and SW2 switch, and all VLANs are forwarding on the link between SW3 and SW1 switch, where SW1 is the root bridge. Pros and cons of PVST+. Cisco developed the per VLAN spanning tree plus protocol, which allows to tune STP parameters for each VLAN, so the root bridge can be placed on a different switch or can cost ports differently on a VLAN by VLAN basis. It allows to block links for some VLANs and forward for others. In this case, the following are true. Optimal load balancing results. One spanning tree instance for each VLAN is maintained, which wastes CPU cycles for all of the switches in the network, and additionally bandwidth is wasted for each instance to send its own BPDUs. In this example, we can see almost the same topology like on the previous slide, but now PVST Plus is configured and SW1 is a root bridge for VLANs from 1 to 500, and port between SW3 and SW2 switches in blocking state for these VLANs, and SW2 is configured as a root bridge for VLANs from 501 to 1000, and port between SW3 and SW1 is in blocking state for these VLANs. So we have some kind of load balancing, but as I mentioned on this slide, spanning tree creates instances for each VLAN, which wastes CPU cycles. Pros and cons of multi-spanning tree protocol. MST combines the best aspects from both PVST Plus and 802.1q and 802.1d standards and gives a possibility to map several VLANs to a reduced number of spanning tree instances. Pros of MST. First one, the desired load balancing scheme can be achieved, and the second one, the CPU cycles are spared. Cons of MST, this protocol is more complex than usual spanning tree protocol, and interaction with legacy switches can be a challenge. So we have example here, we have 3 switches, and SW1 switch is the root bridge for instance 1, and we have VLANs from 1 to 500 mapped in this instance, and this instance is in forwarding on uplink from switch SW3 to SW1, and in blocking on uplink from SW3 to SW2 switch. And we have the second instance for which SW2 switch is a root bridge, and we have VLANs from 501 to 1000 mapped to this instance, and it's in forwarding on uplink from SW3 to SW2, and it's in blocking on uplink from SW3 to SW1 switch. So we have only 2 instances, and we can achieve load balancing, and we can spare CPU cycles in this case. What is MST region? MST region is a group of MST switches with the same high-level configuration, a collection of MST instances that operates in the same MST domain. Each switch running MST in the network has single MST configuration consisting of the following. First is alphabetic configuration name, which is 32 bytes. Second is configuration revision number, which is 2 bytes. And 4096 element table that associates each of the potential 4096 VLANs to a given instance. To be a part of common MST region, a group of switches must share the same configuration attributes. If two switches differ on one or more configuration attributes, they are considered as part of different regions. Region boundary. It is necessary for MST to identify the boundaries of the regions for consistent VLAN to instance mapping. That is why characteristics of the region are included in the BPDUs. The exact VLAN to instance mapping is not propagated in BPDUs. There is only digest of VLAN to instance mapping table. When a switch receives BPDU, it extracts digest and compares it with its own calculated one. If the digest differs, the port on which BPDU was received is at the boundary of the region. A port is at the boundary of the region if the designated bridge on its segment is in a different region or it is receiving a legacy 802.1d BPDUs. What are the MST instances? According to 802.1s specification, MST switch must handle at least two instances. One internal spanning tree IST, one or more multiple spanning tree instances. IST first MSTI in the MST protocol instance 0, which is responsible for building a CST across all VLANs regardless of their VLAN membership. IST contains advertisement for other MSTIs in its BPDUs. Multiple spanning tree instances, they have instance numbers from 1 to 15. The IST runs on all switch port interfaces for switches in the MST region and does not take into account the VLANs associated with the port. The IST BPDU is transmitted through the MST region and includes additional information about other MSTIs. That gives the possibility to the MST to advertise only one set of BPDUs and helps to minimize STP traffic no matter how many instances are there and to provide information to calculate the STP for other MSTIs. IST instances. MST originates from IEEE and must be able to interact with 802.1q based networks, where there is only a single spanning tree, common spanning tree or CST. The IST instance is simply an RSTP instance that extends the CST inside the MST region. The IST instance receives and sends BPDU to the CST. The IST can represent the entire MST region as a CST virtual switch to the outside world. So if we review our topology, we can see that, for example, all these 5 switches inside the MST region, they are like CST virtual switch to the outside world, like we can see on this topology. And all these switches, they consider this MST region as a CST switch, and this switch sends IST BPDUs to the outside world and receives IST BPDUs. From the point of view of CST, this virtual CST switch, it blocks this uplink and this uplink. But if we consider this network like it is without IST, like this having 5 more switches, we would consider, we would expect this interface, for example, to be blocked and somewhere here inside. But in reality, with MST region and with all these IST instances and CST, we have this CST switch, virtual switch, and it interacts with outside world and it blocks these 2 uplinks in this topology. Few more words about MSTIs. The MSTIs are simple RSTP instances run RSTP by default without configuration, existing only inside the region and never interact with the outside of the region, and do not send BPDUs outside the region. Only IST does. The MST runs only one spanning tree outside of the region, so except for the IST instance, regular instances inside the region have no outside counterpart. Switches exchange BPDUs that can be seen as normal RSTP BPDUs for the IST while containing additional information for each MSTI. First information field carried by MST BPDU contains data about the ISP instance 0. So we can see in this BPDU we have first information field which is carrying information about instance 0 or MST 0. This instance presents everywhere inside the MST region. No need to map VLANs onto instance 0, and all other fields in this VPDU are the protocol information for other MSTs. It's so-called M records. Both ends of the link can send and receive BPDUs simultaneously, because each switch can be designated for one or more instances and needs to transmit BPDUs. A BPDU that contains the information for all instances, IST plus MSTIs, is to be sent as soon as the single MST instance is designated for a port. M record fields. Every MSTI assigns its own priorities to the switches and uses its own link costs to build a logical topology separate from the IST. Since MSTP does not send MSTI information in separate BPDUs, this information is added to the IST BPDUs using special MRecord fields, one for every active MSTI. Those MRecord fields using TLV carry root priority, designated bridge priority, port priority, and root pass cost, among others. There is enough information for the corresponding instance in each MRecord to calculate its final topology. MRecord does not contain information about timers, hello, max age, forward delay, which are being used by IST in the MST region. How to configure MST? There are few steps which needs to be done to configure MST. Step 1. Define MST as spanning tree protocol with the command spanning tree mode MST. Then you have second step, and which is optional. In this step you can define the MST instance priority and make, like, if you want, kind of load balancing and assign one switch for one instance as a root switch and the other switch as a root for another instance. And for this you can use command spanning tree MST, and then you use instance number, and then you go you have priority with priority value, which can be from 0 to 64,410 with increment of 4096, or you can use spanning tree MST instance number and then a root with keywords primary, secondary, where you can specify which switch for which instance is a primary root bridge and which one is secondary root bridge. And you have also a keyword diameter, which is used only with instance 0. And keyword primary sets the priority to 24,576, and keyword secondary sets the priority to 28,672. Step number 3. Associate VLANs to an MST instance. By default, all VLANs are in instance 0. So first you need to enter MST configuration submode with command spanning tree MST configuration, and then assign VLANs to different MST instances with command instance number, then you have VLAN with VLAN ID. Step number 4. Specify the MST version number, which must match for all switches in the same MST region, and this can be done with the command revision and version value, and this command needs to be configured under MST configuration sum mode. And the last step is optional as well. Define the MST region name. MST regions are recognized by switches that share a common name, which is an empty string by default. And this is also can be done under MST configuration submode with the command name and then MST region name. MST verification. To verify MST configuration on the switch, use the following command: show spanning tree MST configuration. To see the relevant spanning tree information, use the command show spanning tree. However, the MST instance is provided instead of VLAN numbers there in the output, and the priority value of the switch is the MST instance plus the switch priority. Consolidated view of the MST topology is displayed with the command show spanning tree MST, and you can also filter out by instance number to add this option instance number. To view a specific MST setting for a specific interface, use the command show spanning tree MST interface with interface ID. We can also do some MST tuning. For example, to set interface cost, use the following command in the interface configuration mode: spanning tree MST with instance number and cost with cost value, where cost value is in range from 1 to 200000000. To set interface priority, use the following command in the interface configuration mode: spanning tree MST with instance number, port priority with priority value, where priority value is in range from 0 to 240 with increment of 16. And to change MST timers, use the following command in global configuration mode: spanning tree MST. Then we have three options: hello time, max age, and forward time with time value, where time value for hello time is in range from 1 to 10 seconds, for max age is in range from 6 to 40 seconds, and for forward time is in range from 4 to 40 seconds.
Let's configure multi-spanning tree protocol. We have topology consisting of three switches, and there is at the moment PVST protocol running, and in this case we have SW1 at the root bridge, and G02 interface and SW3 switch is in blocking state. So spanning tree, we can see that there's the SW1 root bridge for each VLAN, and I have also pre-configured VLANs on all these switches. So we have two VLANs already there, VLAN 10 and VLAN 20, and show run spanning tree, and you can see that there is spanning tree mode PVST. So let's go and check let's go and configure mode MST spanning tree MST configuration, and I'm going to map VLAN 10 into instance 1 and VLAN 20 into instance 2. Instance 1 VLAN 10 and instance 2 VLAN 20. And I'm gonna give name MST and revision number 1. Let's go to switch SW2, show spanning tree, same, show VLAN. We have VLANs here, 10 and 20, spanning tree mode MST, spanning tree MST configuration, instance 1 VLAN 10, instance 2 VLAN 20, name MST, revision number 1, and the last switch SW3, show spanning tree and show VLAN. VLANs are there, and mode MST spanning tree MST configuration, instance 1 VLAN 10, instance 2 VLAN 20, and name MST, revision number 1. And now we can see that we have our topology, and we have MST instance 0, we have instance 1, and we have instance 2. Let's go to our switch W1. All is good. So show spanning tree, and we can, to verify, we can use, for example, configuration, and then we're gonna show spanning tree MST configuration, and then we're gonna get our configuration MST configuration output. So we can see that the name MST, revision number 1, instances 3, 0, 1, 2, and which VLANs are mapped to which instances. Spanning tree MST, and then we can, for example, filter out by instance. For MST1, here we can see that which bridge is the root. So this is the root bridge because it is MST1. Let's go and check, for example, on the second one. Show spanning tree MST1. So it says that this bridge is with this MAC address priority, and this is the root bridge, and it's on G01 interface, cost to 20,000, and we can see that G01 root and G03 designated. Then we can, for example, check interface G01, and we're gonna have information about configuration, for example, port guard, BPD filter, which is configured or not on this port, BPD sent, received, and status of ports. Let's go and see what is with our switch number 3. A blocking edge, all good. So we can see that, for example, on switch 3 we have for instance 0, G02 interface and blocking, the same like we had for PVST. For instance 1, G02 blocking state, and G0, for instance 2, G02 blocking as well. So the same topology like we had for PVST. Now I'm gonna make switch SW1 like primary for MST1 and secondary for MST for instance 2, and switch 2 primary for instance 2 and secondary for instance 1. Spanning tree MST 1 root primary, and spanning tree MST 2 root secondary. And let's go to switch 2, spanning tree MST 2 root primary, and spanning tree MST 1 root secondary. So what we're gonna have now, as you remember, it's per instance, not per VLAN like in other protocols. So we can see that for MST1, SW1 is the root. For MST2, SW1 switch has root interface G02, which is facing SW2 switch. And let's go to SW2 switch. We can see that for VLAN instance 1, this switch has root G01, which is facing to SW1, and for instance 2, this switch is the root bridge. And the last one I wanted to show is how to tune some timers, for example, spanning tree MST, and then we have option, we can change, for example, hello timer, let's say to 10 seconds. and then we can change max age for, let's say, 20, and last one, forward delay, forward, let's say also, let's say 15 seconds. So we can see it's in place already here. And for VLAN MST1 and for MST2, but this is, let's go to switch SW2 and check what we have here. 2015, and we can see for instance 0, switch SW2 has from the root bridge it has hello time 10, max age 20, forward delay 15, but locally configured to 2015. And let me change T spanning 3 MST max age, let's do it 15, and forward delay also 15, also 15, 15 15, 10 15 15, MST1 10 15 15, and here you can see 10 15 15 for the root, and for locally configured we have 2 20 15. The same for MST1 and the same for conf T 3 spanning 3. If you remember, these timers, they are sent in IST BPDU, and they are not sent in MSTIs. So that's why we have all this for MST1 to 0 from SW1, from switch SW1, all these configurations, all these timers, even on the switch SW2 for MST1, MST2, where this switch is the root bridge, but still we have hello time 10 seconds, 15 seconds, and 15 seconds, because these timers, they are sent by IST BPDUs, and this is instance 0, which is configured on the switch SW1. And last one, let's go and check connectivity. So our PC1 has it's in VLAN 10, and it has 172.30.10.10, and PC3 is also in VLAN 10. PC3 if config, this is the IP of PC3, and we can see that connectivity is there. And PC2 in VLAN 20 if config 172.31.20.10, and PC4 is also in VLAN 20. It's PC4 if config. Let's copy and ping. And connectivity in VLAN 10 and VLAN 20 is okay. Here is the link that I used during preparation to this video. I hope it's gonna be very useful for you as well. And this concludes part number 1 of multiple spanning tree protocol video. I hope you liked this video, and please subscribe to my channel. Thank you very much for your attention. I hope to see you soon, and wait for part number 2. Ciao, ciao.